All right. Algebra 1, folks. We are starting lesson 42. Lesson 42 is about factoring trinomials where a this time is greater than 1 instead of a equaling 1. Okay. Lesson 41, all of your trinomials, a equaled 1, and now we're going to see what happens when a is greater than 1. Let's go ahead and start filling out a couple of blanks here. It says sometimes we are given a trinomial where our a term is greater than 1. Okay. Kind of speaks for itself there. So we're looking here at this, right? Just as an example. So now we're noticing in front of that a squared, it's not a 1 or there's not nothing representing a 1. We have a 5 there. Okay, so that's different. It says here on this next sentence, it says, because of this, the exact steps used in lesson 41 to factor trinomials do not work. Okay, I'm going to show you why. On your last set of notes, you were going over to term C, right? Here's term A, term B, term C. You were going to C. You were listing its factors. The factors of -4 are 1 times -4, -1 times 4, and -2 times 2. And we were having to pick one of these three pairs that added up to our B term, okay? Well, here you notice for the first time, none of these three pairs add up to -8. So right off the bat, we're saying, hey, look, this doesn't work anymore because our A is greater than 1. Okay, so what does that mean for us? It means we have a little bit of extra work to do. It's not hard work, just a little bit of extra work. Okay, and I'm going to explain that to you here in these next few opportunities below. Here in this third sentence, it says we will have 2 extra steps. Excuse me, I'm going to fix that if it would let me. We have 1 extra step at the beginning and we have 1 extra step at the end. We taught you 3 steps on our last lesson. Okay, now we're going to have 2 more. One of them is at the very beginning and one of them is at the very end. Let's go ahead and take a look at them. It says here were our previous steps from lesson 41, but let's add our 2 new steps. We can call them step 0 and step 5 just for the sake of being easy. Really should probably be 0 and 4. That's a typo on my end there. Okay, so here's what our first new step is. We're calling this step 0. The first thing I need to do is I need to multiply A by C. Okay, so I'm taking this first term and I'm multiplying it by this third term. So I'm doing 5 times -4. Okay, and that gives me -20. That is now my number that goes up here in the top of this X. Okay, so now we need to find 2 numbers that multiply to C. This is not a new step. Multiply to A times C. So there's our -20. B, those same 2 numbers must add to B. So that is not a new step. Step 2. Step 3, write your answer as 2 binomials. So that also is not new. And last but not least, try to divide both binomials by A. Okay, so we're going to go ahead and focus on this one here, this example to our right, and we're going to get a chance to dive into a few more examples to make you feel confident and comfortable adding in these 2 new steps into the 3 steps you learned from 41 and factoring trinomials. So the first thing we did again, right, was we did this number up top came from our first new step, multiplying A times C. That got us -20. Now I need numbers that multiply to -20 that add to -8. I think I have those 2 numbers in my head. Those numbers are -10 and +2, right? -10 times +2 is -20, and -10 times -10 plus 2 is -8. So I found my pair, right? My 2 numbers I was looking for, my factor pair are -10 and 2. So we're going to go ahead and start setting up our binomials here. All right, I'm on to step 3. What we noticed in our last set of notes was that we would take the coefficient that was out in front of our first term, in this case A, right? And we would just have maybe A and A, okay, leading both of our binomials. Now, since that first term is not just A squared, it's 5A squared, we need that 5 in both of these spots. So this 5 is coming strictly from my first coefficient or my leading coefficient of this trinomial. I have 5A and 5A, that's new. Okay, this next part isn't new. I'm taking my 2 numbers, my -10 and my +2. -10 positive 2. Okay, and I now have two binomials, and I'm on to step 5, right? Because I've gotten through 0 through 3 pretty quickly. Again, this should say 4, if I'm being honest. Okay, and I need to try to divide both of these binomials by whatever my a term is. Well, my a term is 5, so I'm going to try to divide this by 5, and I'm going to try to divide this by 5. When I say try, you're going to see what I mean. I'm looking at this first one. 5a divided by 5 is just a, because 5 divided by 5 is 1, and negative 10 divided by 5 is negative 2, so we were able to clean that one up with division. This next one I'm noticing 5a divided by 5 again is a, but 2 divided by 5 is going to be 0.4, and we don't like that, and I also don't want a fraction, so I'm actually just going to leave. I'm not going to divide this one. I tried. It didn't work. I'm going to leave this one as 5a plus 2. Okay, and what we need to do is we need to make sure that when I've completely found my answer here. Here's my factored version of this trinomial we were given at the start. If I want to check my work, what can I do? I can use this box method to see, hey, did I do all that factoring correctly? I can take my answer and see if it gives me back my original problem. So I would have my first one, a minus 2 here, and 5a plus 2 here, or positive 2. 5a times a is 5a squared. 5a times negative 2 is negative 10a. A times 2 is 2a. And 2 times negative 2 is negative 4. I can pull my terms out one at a time and combine like terms. So 5a squared, done. These next two terms both have an a. That adds up to negative 8a, done and done. And that leaves me with a negative 4. Okay, so there I have my terms listed for that trinomial, and that is exactly the same as how my problem started. So let's go ahead and check a couple more examples. I think this is one of those things where the more we do, the more confident we're going to feel, or the more we see, the more confident we're going to feel. All right, so let's check these ones out below. I've got another example here. This first trinomial that we're given here is this guy right here. Let's switch up colors so we can tell a little distinctly here. So now we'll rock the blue, and we're seeing that this says 3n squared plus 13 plus 4. If you want to know right off the bat, again, why do we have these new steps? Our old steps said to go here, find the factors. That'd be 1 times 4 and 2 times 2. 1 plus 4 is 5. We need it to be 13. And 2 plus 2 is 4. We need it to be 13. That's not going to work. No can do. So we follow these new steps. What are these new steps again? Let's go ahead and bust them back out. Step 0, multiply. Saying this one right here. Multiply a times c. So now I'm taking 3 and 4, and I'm multiplying. Well, 3 times 4 is 12. So I'm putting 12 up here. And I know my b term goes below 13. So I need two numbers that multiply to 12 that also add to 13. So what are my factors of 12? My factors of 12 are 1 times 12, 2 times 6, and 3 times 4. Which of those pairs adds to 13? It'd be the top pair, right? 1 and 12. Okay, so here's my two numbers that add to this and multiply to this. Okay, so let's go ahead and start. We've now done step 0, step 1, step 2. We need to write our answer as two binomials. What's different now? Instead of just having my variable leading both of these, I need my coefficient and my variable. So I'm looking at a. I have 3n here and 3n here. I have my two terms, a positive 1 and a positive 12, plus 1 plus 12. Doesn't matter which binomial you'll write them in. And then step 4, this last new step, try to divide both of those by what a is. So a is 3, right, or a positive 3. So I'm going to try to divide this one by 3, and I'm going to try to divide this one by 3 and see which ones work. 3 divided by 3 is 1. That's great. 1 divided by 3 is going to be 0.33, or 1/3. We don't like that. We're not going to divide this one. Let's just keep it as 3n plus 1. Over here, 3 divided by 3 is n, or 1n, and 12 divided by 3 is 4. That one can be simplified, right? We like that one. Okay, I could, again, box method this back out, 3n and positive 1, and n and a positive 4, and my result should be my original problem. That means I have done my factoring correctly. Okay, let's take a look at a few more examples down below. that have some positives, some negatives, some different things going on, some bigger numbers, some smaller numbers. Let's kind of jump around some of these problems. So let's go ahead and start with problem number 1. Let's switch up our color here again. Let's go with, let's rock a red. Okay, so for this first one, my first step, multiply A times C. 3 times negative 5 would be negative 15, right? I want my magic X. That's where that one, class change. See you guys next period. No, we're going to stick around. We're going to finish this. So I need things that multiply to negative 15 and then add to negative 2. So we're thinking, what are our factors of 15? We have really, right, we have 1 times 15 and we have 3 times 5, right? And I know these are negative, right? This should be a negative. So one of these is going to need to be negative and one positive. And I need to add to negative 2. 1 and 15 can only get me 14 or negative 14 when I add. So it's not that one. 3 and 5 can, right? I could get 2 or negative 2. Which one needs to be negative? My 5 needs to be negative. So I have negative 5 and positive 3. Grab a calculator, double check. Really just let the calculator do the work for you if you're not 100% certain there, right? Negative 5 plus 3 is negative 2, and negative 5 times 3 is negative 15. Let's go ahead and start creating our binomials. I'm looking at my A term. That's what goes first. 3p and 3p, and then my factor pair next. So it doesn't matter which one goes where. I'll go negative 5 here, and I will go positive 3 here. And I'm going to try to divide both of them by 3 because 3 is my leading coefficient, right? It's in front of A. Divided by 3. 3 divided by 3 is 1. You're going to notice that happens really on all of these. 5 divided by 3 is going to be 1.66. That one doesn't work for us. Let's just leave it as 3p minus 5. We can't divide that first one. That means we should be able to divide the second one. 3 divided by 3 is 1. 3 divided by 3 is 1 again, so I should have p plus 1. There's my complete factored form of this original trinomial. Awesome stuff. All right, let's check out number 2. Problem number 2. Again, this should start to become routine. A times C. 2 times 9. We get negative 18. Ooh, it's a little rough looking. And they need to add to 3. So think about what your factors of 18 are. My factors of 18 should be 1 and 18, 2 and 9, and 3 and 6. These should really start to jump out to you pretty quickly. There's nothing I can do with 1 and 18, addition or subtraction wise, to get 3. Same with 2 and 9. That would get me 7s and 11s. But 3 and 6 can, right? How do I get a positive 3 out of a 3 and a 6? Well, I should have a positive 6 and a negative 3. Should be my 2 magic numbers there that we're looking for. Go ahead and set up our binomial. So I have 2n. I have another 2n leading the second one. Here's take my 2 numbers. We'll go negative 3 here. We'll go positive 6 here. And we need to try to divide this by 2. 2 divided by 2 is 1. 3 divided by 2, negative 3 divided by 2 is not going to work. Let's leave it. Let's check out this next one. 2 divided by 2 is 1. So we're going to have n left over. 6 divided by 2 is 3. Box method that bad boy back up and make sure that you get this original trinomial there. Let's keep it rocking and rolling. Let's grab a couple more of these. I'm going to notice we're getting into a nice routine here. 3 times 4 is 12. That's positive. I need things that multiply to positive 12 that add to negative 8. Okay, so factors of 12, 1 and 12, 2 and 6, 3 and 4. How can I get 8? Not that one. That gives me 7s and 1s. This gives me 13s and 11s. This guy's going to give me an 8, right? I need a negative 8. So I need a negative 6 and a negative 2 to give me a negative 8. And negative 6 and negative 2 gives me positive 12 when I multiply. Let's set these up. I take this down to tell me what leads both of these binomials. So 3n, and then I have a negative 6 and a negative 2. Which one of these can I actually divide by 3, right? It's this one. Because 3 divided by 3, 3n divided by 3 is n, and negative 6 divided by 3 is negative 2. I can't do it here because 2 divided by 3 is going to be a fraction or a decimal. We want to avoid that. So we keep this one, just bring it down. 3n minus 2. We're rocking and rolling. Let's go ahead and knock out maybe 1 or 2 more. I like this next one because it gives us a bigger product of A and C. We need 5 times 12, which is 60. And I need it to add to 19. Ooh, so I'm thinking factors of 60 that add to 19. 1 times 60, 2 times 20, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. I think that's all of them. Big factorless. And I need 19. You should be noticing, hey, 4 and 15 can give me 19. We like number 4 because everything is positive. That means we are positive that we have it right. So let's go ahead and set these up. I have 5n, and I'm taking my factor pair of 4 and 15, both positive, plus 4, plus 15. We should recognize there you go. You should be in class. Class has started. We should notice I need to divide by 5. That's only going to work on the second one to give me a nice whole number answer. So 5 divided by 5 leaves me n. 15 divided by 5 is a 3. And then I have this 5n plus 4 that was not able to be reduced or divided to give us the kind of numbers that we like to work with there. Let's check out. Well, let's pick one of these two. Let's go ahead. Which one do we want? Let's end with number. They're so similar. Let's go ahead and end with 5 here. 2 times 5 is 10. They need to add to 11. You should be thinking right away, hey, that's just 1 times 10 is 10, and 1 plus 10 is 11. So let's go ahead and set these up. We have 2v plus 1. We have 2v plus 10. Which one can I actually divide and get a nice integer answer? That would be this one, divide by 2. 2v divided by 2 is v, and 10 divided by 2 is 5. This one's going to stay as 2v plus 1. Right, box method that back out to check and see does my answer here give me the original trinomial I was working with. So hopefully that gives you some insight to what do we do? Again, why different? What's different about this lesson? All of these leading coefficients, we have a 3, we have a 2. Down here, what do we have? We have a 3, we have a 5, right? All of those, go back to our first mention here, those were all greater than 1. So we have those extra 2 steps when a is greater than 1. It's a good habit to even just start using that when a is 1 so that you don't forget to do it when a is greater than 1. Hop into either traditional practice, Delta Math, error analysis, Flipgrid, and let your teachers know how they can help. Thank you for following along. See you next lesson.